All right, today we're diving into a really cool new library from Hugging Face called Daggr. And listen, it promises to fix one of the most frustrating parts of building with AI. Actually debugging those super complex workflows. So let's see how it actually works. So if you've ever tried to string multiple AI models together, you know this feeling, right? It's like building this delicate house of cards. One little shaky API call, one wrong move, and the whole thing just comes tumbling down. It's painful. You're constantly wrestling with these fragile API calls, right? And you're trying to hunt down a bug in this long chain where all the middle steps are completely invisible. But you know what the worst part is? When one tiny thing breaks on, say, step 7, you have to rerun the entire 10-step workflow all over again. It really feels like you're stuck between two bad options, these flimsy little scripts that are impossible to debug, or these super heavy platforms that are just total overkill for trying out a new idea.
Well, this is the exact problem that Daggr was built to solve. It introduces this brilliant new idea, code meets canvas. And the whole goal is to give you the power and flexibility of code, but with the crystal clarity of a visual workflow. It's the best of both worlds.
So what is it exactly? Well, Daggr is an open-source Python library for building AI workflows. But here's the magic trick. As you write your code, it automatically generates an interactive visual canvas of what you're building. You just write standard Python, and boom, you get this powerful visual debugger essentially for free. This chart really nails the difference. I mean, look at the old way on the left. You're trapped with these fragile scripts or these clunky GUI tools that are totally disconnected from your code. Now look at the Daggr way on the right. Your workflow is just clean, version-controlled Python. That impossible to debug mess? It's replaced by an auto-generated visual canvas. In the big one, instead of rerunning everything, you can inspect and rerun just the one single step that failed. Let's just quickly run through the core features here. First, the canvas is generated from your code, which means your code is always the single source of truth. You can inspect the output of any single step and rerun it by itself. That is a massive time saver. It also has incredible Gradio integration baked right in, and it automatically saves your workflow state so you never lose your place.
So how do you actually build a workflow in Daggr? Well, it all comes down to combining 3 fundamental building blocks. Daggr calls these nodes.
And here they are. First up, the Gradio node. This lets you tap into any existing Gradio app out there and use it as a step in your pipeline. Super useful. Next, the FN node is for all your own custom logic. You just wrap any Python function and it becomes a building block. And finally, the inference node connects you directly to models on Hugging Face. Seriously, with just these 3 node types, you can build some incredibly powerful stuff. Okay. Theory is great, but let's see how this actually works with a real-world example. We're going to build a pipeline that takes a simple image and turns it into a 3D asset. So here's the game plan. It's a 4-step process. First, we'll remove the background from an image. Second, we'll downscale it just to make things run a bit faster. Third, we'll enhance the image to give it more of a 3D-friendly style. And finally, we'll generate the actual 3D model. All right, for our first step, background removal, we're going to use a Gradio node. I mean, why build it from scratch, right? This node just calls an existing Gradio space that's already amazing at this one task. We literally just plug our image into a service that already exists. Easy. Now, for step 2, we need a little bit of custom logic. We just want to resize the image. So we'll use an FN node. We write a simple Python function to downscale the image, wrap it in this node, and that's it. It's that easy to inject your own code right into the pipeline. Okay, now for the fun part. In step 3, we use an inference node to call a specific model. This model is going to take our clean, downscaled image and transform its style into something that's really optimized for 3D generation. And to finish it all off, we use another Gradio node. This final node takes our newly styled image and sends it off to a totally different Gradio space, one that specializes in generating 3D models from 2D images. And just like that, our 4-step pipeline is complete. So here's the crucial point. Once you've defined these 4 nodes, the 2 Gradio nodes, the function node, and the inference node, chaining them all together in your code is incredibly straightforward. It's just a few lines to connect the dots. So are you feeling inspired to try it out for yourself? Well, getting started with Daggr is ridiculously simple, so let's just quickly walk through how you can get your hands on it. Installation is literally just one line in your terminal. Pip install Daggr. That's it. You're ready to go. Now, just a few quick things to keep in mind before you dive in. You are going to need Python 3.10 or higher.
And remember, Daggr is currently in beta, which just means some of the APIs might change a little bit as it evolves. The team is actively looking for feedback, so feature requests and bug reports on GitHub are super welcome. Ultimately, Daggr offers a powerful and I think much more intuitive way to approach building and debugging AI. It's real proof that even if your AI workflow is complex, your tools don't have to be. So the only real question left is, what are you going to build first?